All right, number one on the concept mastery worksheet. Hey, the really helpful thing here is going to be part B, where I ask you to find the work done by gravity. There's something really cool about the work done by gravity. It turns out to be equal to the change in potential energy of the object, which I'll show you in a second. Okay, so we have this 1 kilogram ball being dropped from rest. V initial is 0, and it falls down, and we're given the velocity right before it hits the ground. Okay, right before it hits the ground, it has a velocity of 20 meters per second. So let's look at the mechanical energies initial and the mechanical energies final, and what we're going to see is that the ball down here ends up with less mechanical energy than it started with. Now, what's going to account for that? Why is there going to be less mechanical energy at the end? Because what was stealing the mechanical energy as the ball fell? Air resistance, which is like a type of friction. Okay, so let's go through the mechanical energies. So initial up here at the top. Does the ball start with kinetic? No, because it's not moving. Does the ball start with potential of gravity? Yes. Now listen, whenever you deal with potential energy of gravity, you have to set your 0 point, and the 0 point is where H gets measured from. Remember, the equation for potential of gravity is mgh. Where does H get measured from? The 0 point. So where's the point for this problem? You should put it down here. This is the best place to put it. Like that. And just realize, if you wanted to make life incredibly difficult, or maybe not incredibly, but more difficult, you could like put your 0 point there if you wanted to. It's still solvable, but then what would happen is once the ball passes the 0 point, down here you'd have negative potential energy. So look, as a general rule, you just want your 0 point to be at the lowest point in the problem. So do we have potential of gravity at the start? Yeah, because it's above the 0 point. Okay. Any spring energy up here? No, that's 0. Okay, work non-conservative. For this problem, it's going to be the work done by the air resistance. All right, down here, final. Does the ball end with kinetic? Yeah, because it's moving. Does it have potential of gravity? No, because it's on the 0 point. Does it have spring energy? No. So what we're left with is this. We're left with potential of gravity initial plus the work done by the air. Now, guys, realize we're going to find out in a second that this work of air has to be negative. Let's just leave it plus for right now. Plus work of air equals kinetic final, right? Okay, so you calculate these values. Potential of gravity initial comes out, when you do mgh, comes out as 294. Kinetic at the bottom comes out as 200. The equation for kinetic is 1/2 mv squared. So look, here's what we get. 294 joules plus the work done by the air resistance equals 200. What must be the work of the air? The work done by the air is what? Negative 94. Now, why does it make sense that it's negative? Well, what's the sign convention for work? Sign convention for work in the direction of motion is positive, against the motion is negative. As the ball falls, which way is the air resistance working? With the ball or against it? Against it, which is why the ball loses mechanical energy. Okay, part B, finding the work done by gravity. So watch, this is real cool. Look, as the ball falls, we have force of gravity pulling it down, right? Who remembers the equation for force of gravity? It should be like engraved in your brain by now. mg, force of gravity equals mass times gravity, right? Now look, what's the basic work equation? Work equals force times displacement. Are you ready to see something cool? Are you ready to see something cool? What would work of gravity be? The work of gravity is going to be force of gravity times displacement, right? So watch. What's work of gravity? I'm sorry, what's the force of gravity? mg. Now, what's the delta x here? Remember, when you use this work equation, the force and the displacement have to be parallel, right? So what is this displacement? It's the height, right? It's the height that it's falling through. And then what's mgh? Mgh is what? That's the equation for potential of gravity. Now listen, the work of gravity is always equal to the change in the potential energy. Now, so we know the work of gravity is going to, you punch in mgh, you get 294. Is this going to be positive 294 or negative 294? Positive. Now, can gravity do negative work? It sure can. That would be if what? That would be if you had a guy down here who throws the ball up. If you throw a ball up in the sky, then gravity is doing negative work because it's opposite motion.